So let's look at data types in object-oriented programming languages. So we have seen in previous videos that we've got all kinds of data types. Enumerations for numbers, for strings, booleans, bits, characters. We've seen each one of those a little bit more detail. In object-oriented programming, we also have these data types. Some of them are primitive types, which are not objects, but most of them are just also objects. Like, for example, a string. A string in an object-oriented programming language is just an object. So a string is a class, and specific strings, sequences of characters, are instances of this class string. And then the class string defines the operations you can do on strings, like, for example, print them. But we need more than these primitive or basic data types. And we can define our own data types in object-oriented programming by defining what is called an abstract data type, an ADT. An ADT consists of some data and operations that we want to do on this data. And if you think about our definition of class, you actually see that this is exactly what we've defined in a class. Some variables and some methods. Some data and some operations that we can do on some data. Let's have a look at some examples of abstract data types that we have in object-oriented programming languages. An array. An array is a collection of data items. Here on the slide we see this collection of data items. Yeah? The blue ones are the data items, and this is the one we store them in an array. The array is called C. It stores integers, and in this example has 8 integers. And here in this statement that is reflected here on the slide, you see that we have initialized it with these 8 values. 45 is at position 0, 6 is at position 1, 0 is at position 2, 72, and so on and so on. And in position 8, there is at position 7, there's 62. So see that the position starts counting at 0. So from 0 to 7, we've got 8 data items in the array. So this is a typical array that contains integers. And this is what is called a homogeneous array, because all the items in the array have the same type. We can also have things like heterogeneous arrays. Then it's the same, but it can have different types of items. So it can have integers, strings, and other type of objects. So elements in these type of arrays are normally accessed by the position in the array, like you can see here. C5 has value minus 89. Here you see it. At index 5, there's this number. C0 has value 45. As you can see here at position 0, there's 45. So this is an array, generally. So how can we make these arrays in object-oriented programming? So we make an ADT, an abstract data type, operations and data. So the data is just your items you want to store in the array, which in this example are integers. So what are the operations? Well, you've already seen before that the only thing we want to do with an array is get some element from a specific position and set some element in a specific position. And obviously it would also be handy to know if the array is full or if it's still empty and it doesn't contain any elements. So here you see a definition of an abstract data type for arrays. We've got data, which is the items we want to store, and we've got the operations. Get an element from a specific position I, set an element to a specific value at a specific position I, is full and is empty. And using the notation we've seen before, then it means that get I from the array C is written like Ci. Okay, and set the same, it's just assign to Ci the value of V. So this is arrays. So a disadvantage of arrays that you can imagine of is that it's a sequential representation of data. So imagine I want to insert this brown item into the array on the slide. I have to move all the elements aside to fit the new item in. And obviously this is slow because this costs processing time and because we have to move all the elements. So to get over this disadvantage of arrays, we want to look at another abstract data type, which is linked lists. So if we have an array and it's difficult to insert a new element, look at the linked list below. Imagine that I want to insert this brown element into this position of this linked list. Well, this is easy. I just say, okay, the next item of 2 is now my new brown element, and the brown element's next element is what was previously at the third position. And I've got it inserted. So I only have to move these 2 arrows, which are called pointers. Here's a linked list and a terminology. This is the head of the list. This is the tail of the list. And here you see these little arrows that indicate that you go to the next element are pointers. And so we make a list of elements that are linked together by pointers. So, as an abstract data type, this means that the data are the items that we want to store. And as operations, what we want to do is, for example, prepend an element to the beginning of the list, append an element with value v to the end of the list, insert an element with value v at some position I in the list, delete a specific element, and look if the list is full or empty. So this is an abstract data type for linked lists where we have data and operations. In the next part, we'll look at some more data structures.